Hello again, everyone. This is just a quick update for my Analema challenge. It's not an easy task for me because it requires a lot of heavy trigonometry, which I know only basics about. So this is the Analema that we all see in many places or many sites. And when I tried to produce it on a spreadsheet, uh, this was the first thing to come out, and then this, and then this. And in this model, this figure of 8, this is how should the analema happen if we are in circular orbit. I'll explain why the sun moves left and right. And then after a little bit of enhancement, I got this, and then this, and this is basically the same one, but it's a little bit squashed. These are almost 5 degrees. They should be 8 degrees. But anyway, why the analomy happens? We go to Google Earth. So now I'm going to explain why the shape of the analema happens, but I'd like to go back to the figure of 8 just to explain it. The vertical axis represents the elevation angle. It's plus 23 and minus 23, 23.5. So that's for the vertical axis. Is the elevation angle of the sun along the year. The horizontal axis, or the x-axis, is the sun direction every 24 hours. So if at 12 noon every day you'll see the sun moving to the right and then start moving to the left, and so back to Google Earth. This is the Earth. Of course, it's not tilted yet, and I just presumed a circle of a 5 degrees radius. 10 degrees radius. This red line is the line where the connected line from the sun to the Earth slice through the surface of the Earth along the year. You need to ignore the features of the Earth, because I'm not talking about the Earth rotation. I'm talking about the Earth orbit. And due to Earth orbit and its axial tilt, this is how it's tilted. The Earth is moving that direction, and we are the sun, so the sun is slicing through that line till the summer, and so on. So for simplicity, I'll assume that the Earth rotation is 10 degrees per day, and the Earth spin is 10 degrees per day. That's almost the case, because the Earth rotates 1 degree per day around its axis, and the position of the Earth changes by 1 degree in relation to the sun, around 1 degree every day. So let's put the Earth back to its angle. So if the sun moved 10 degrees after 1 day, it is on this longitude. So the sun on this longitude. Now this longitude, if it moves 10 degrees after 1 day, it's here. So the sun is behind the same longitude that it was perpendicular to just 1 day ago. And as we move to the summertime, the circle is also 10 degrees in radius. So by the time the sun covers this length, that is 10 degrees, look where is the Earth. The Earth distance is shorter because this is the 10 degrees. And you now may wonder why am I saying that this circle is 10 degrees in radius, but here it's more than 10 and a half, because it is on a higher latitude. If you pull the circle down to the equator, then it will fit on the 10 degrees. So the red line represents the sun speed, the yellow line represents the Earth speed. The Earth is obviously slower, and here the Earth is faster. So the relative position of the sun comparing to the relative position the day before changes according to that speed. That only explains the figure of 8, this perfect figure of 8. Now, so for this classic analema that we always see, at this point in January, around 3rd of January, the Earth is in closest path to the Sun, and so it's faster, and this means that the angle of position change is more, and the Earth's rotation, the Earth's spin around its axis cannot cope with that excess speed, and that's why the Sun moves further away from the south or the north, according to where you're measuring from. I hope this was simple enough. I'm still stuck with a problem here. That change of speed depends on two factors. First thing, the direction of where the sun is moving. As you can see, if it's moving higher, more than 23, which is not realistic, but as it moves higher, its relative speed is slower compared to the Earth. So this angle, I know that right here on the equinox, it's 23.5. But during the summer, the angle changed, and I don't know how to do it. I just made some sloppy mathematics to get an approximate, but I still need the correct equation. I'm trying to, but it's kind of hard for me. So that's the first thing I need to know, the angle. Or this is my only problem now, because the other factor is how much latitude lines this circle is covering. As you see on the equator, it's covering 20 degrees from side to side, and here on the Tropic of Cancer it's covering more, and I can calculate this, no problem with that. And my only problem is need to know this angle. I don't even know what to call it. If I get this angle, I can know the change of speed along this path of the sun. Thank you all for watching.